All right, all right, all right. Let's bring the pain. We are going to do f of x equals x squared over x squared minus 1. Okay? So our domain, this is not a polynomial. So like where does the bottom equal 0? The bottom equals 0. We're going to set it equal to 0 and solve. And if we solve, we get 1 and negative 1, which is not what I wrote there. I should say plus or minus 1. So those are our bad juju points. We cannot have stuff there. So we have our domain of, this is the official way of writing it in interval notation, okay? We do our intercepts. The x-intercept is when y equals 0, so we set it equal to 0. The bottom doesn't matter here, only the top matters when you're trying to solve for 0. So x squared equals 0 at 0, and if we plug 0 back in, we already know that our y equals 0 there, so 0, 0 is our point. When you do the y-intercept, x equals 0, you get the same point for both the x-intercept and y-intercept. Okay? If you want, on a piece of scratch paper on the side, I'm not going to do this because I've got lecture notes here. But on a piece of scratch paper on the side, start plotting shit. Mark your intercepts. Start doing them as you're going. Build them on some scratch paper so you can put all this shit together easier later on. Okay? End behavior, we look at the limit as x goes to plus or minus infinity. Since this is a rational function, we want to look at what's happening here. The top and bottom have the same numerator or same degree. So we're going to have a horizontal asymptote. And so we need to kind of figure out what it is. We can multiply by 1 over x squared. On top and bottom, that gives us 1 over 1 minus 1 over x squared. Now it doesn't matter which infinity we plug in, we just get 1 over 1, which is 1. We have a horizontal asymptote of y equals 1. So if you're sketching your graph up there, you might have your point here, and you might have a little dotted line right here. And you might even have, our vertical asymptotes are coming up at 1 and negative 1. You might put those in too. You might have that all good to go so far. Okay? That's my pro tip on how to do this stuff. I should have mentioned it in the last video. And I didn't. Oh well, get over it. Vertical asymptotes come from our domain. Good to go. All right, derivative time. Fun. We need the derivative. So quotient rule. You could have done a product rule, move it up to as a negative exponent. I think more of you tend to mess that up. But if you do this, you're going to get negative 2x squared over x squared minus 1 squared. The quantity x squared minus 1 squared. So the bottom is positive everywhere, except at 1 where it equals 0. Anything squared is going to be positive. So that ends up being positive everywhere. So when we're looking at our sign chart, we don't even need to keep it in mind. So to find our critical points, we do count it for critical points though. So we are going to have a critical point at plus or minus 1. And the top gives us a critical point when we set it equal to 0 if x equals 0. Okay? So I've got my asymptotes, or not my asymptotes. Yeah, my asymptotes are at negative 1 and 1. We saw that earlier. And we're looking for what happens at a critical point 0. Doing little regions here. We're checking the first derivative. I just used like what I could. I tend to do powers of 10 when I can. And then I tend to like just do as simple as I can in the middle. So if I do, and the top is the only one that matters because the bottom's always positive. So if I plug in negative 10 here, this is a plus. And this is a plus also. And then the next two are negative. So we can see that we have it's increasing from negative infinity to negative 1, and then from negative 1 to 0. It's decreasing from 0 to 1, and then 1 to infinity. It's not increasing or decreasing at 1. In fact, those are asymptotes. So we do not want to just say negative infinity to 0. That would be wrong. And 0 was not an asymptote. This is going up and then down. Looks like x equals 0 was a max and x equals 0 was our intercept up here. So we know we have, last we saw, we had this going on. Some asymptotes like that. We had some asymptotes like that. We had a point there. We had an asymptote at y equals 1. And it looks like x equals 0 is a max. So it looks like it's going to do some shit like that because it can't cross the asymptotes if we're building our graph right now. Okay? So if you're building your graph live on the side, you can do all that stuff. Do not throw this shit into Desmos and do it right away that way. Do this by hand and then check your work on Desmos, okay? Because on the test, you will not have Desmos. There ain't no checking your phone. There ain't no going out, taking a break. You got to do this without looking shit up. You got to know how to do this. Second derivative wasn't any fun. I did it off of here. And I didn't distribute right away. I noticed when I got here, the bottom has x squared minus 1. I have an x squared minus 1 here with everything multiplied together there. And I have an x squared minus 1 here with everything multiplied together there. This is just like a minus b. And they each have an x squared minus 1 in it. So I can cross that out with one of the ones on bottom. Okay? So this ends up being to the 4th power. It gets knocked down to the 3rd power. That one goes away, and this one drops down to 1. So that's what we see here. A 1 there, a 3 there, and it doesn't show up on the other one. Now I started, this makes it so much easier to do it if you cancel out shit that way first. If I multiply it all out, I get 6x squared plus 2 on top, x squared minus 1 cubed on bottom. The top is positive for all x. Remember, upside down A is for all. So the top is always positive. When we're checking concavity, we only really got to check the bottom. It is giving us critical values at plus or minus 1. Notice how I lined it up underneath my other one so I could kind of like take a look at what's going on there. When we're plugging in like negative 10, only the bottom matters. A negative 10 squared is 100. 100 minus 1 is 99. 99 cubed is positive. I don't know what it is, but it's positive. So positive means concave up, opening up. You check the other one. 0 is kind of easy to plug in. You get negative 1 cubed, which is negative 1. And you plug in 10, you're going to get the same thing as negative 10. So we get 2 regions of concave up, 1 of concave down. Concave down does match our idea that that was a max, like we said over here. So we confirm that there. And now if you've been plotting your graph all along on scratch paper, you'll see that we had our asymptotes. Got our asymptotes. Earlier, we had identified our intercept. We had seen this part. It told us it was increasing and on the outside those, well, it said it was increasing from here to here, and it said it was decreasing from here to here. But how that helps us with the asymptotes is kind of iffy. So the concavity kind of helps here. It is concave up on over here on the left, which means it's doing that. It's also concave up here, which means it's doing that. And we see that's what we get. All right, I got one more problem for you. That was kind of long. I'm gonna make it a 3rd FML video.